So following on from some of our earlier videos, we were trying to sketch the graph of this function here, and we got to this stage here where we guess our graph to look something like this. Okay, and right at this point here is pretty much vertical here. So now we need to detect the points of inflection. So starting with this, we need to differentiate it. That would then give us this, which we covered in some of the earlier videos. So to detect the points of inflection, we need to differentiate this again. So now we need to differentiate this. Okay, so rewrite this as this. Okay, rewrite that. Rewrite this as this. Okay, and then tidy this up. Tidy this up. It will become this. So now it's easier to differentiate. So this is still f prime. So to find out f double prime, we need to differentiate this. So what you've got here at the moment is this block multiplying with this block here. So we need to use the product rule here. So the product rule is differentiate this, leave this the same, and then leave this the same, differentiate this. So when you differentiate this, it will give you this. Okay, so now tidy this up. Tidy this up. So visualize this here as well. You've got a negative here. So visualize this thing here as 1 over x to the power of 3 plus 2 to the power of 4, positive 4 over 5. Okay, so here you've got a negative, but visualize this block here as this. Okay, so what you have here is this block multiplying with this block plus this block multiplying with, well, you've got a block here, and a block here. Tidy this whole thing here up. It will give you this. Okay, and then here what you've got is one fraction taking away this fraction here. So in order to merge the two fractions, you've got to get the two denominators to be the same. So times top and bottom here by this thing here. Okay, and then you will get the two denominators to be the same. So when you multiply top and bottom by that thing, it will then give you this, and then this stays the same. Okay, so the good thing is that the two denominators here are the same, so you can start to merge the two. So merging the two fractions will give you this. Yeah, it will give you that, and then to the power 4 to the power 4, you can merge these two together here. That will then give you minus 6x to the power 4. Okay, so now to detect our points of inflection, we need to inflection occurs when f double prime equals 0. So it occurs when you set this to be 0. So set this thing here to be 0. So looking at this, when you set it to be to 0, it will then give you this. Okay, so now find out when this thing equals 0. You see, this thing here equals 0 when this alone equals 0. Okay, so basically you want to find out when this whole thing here equals 0. So just concentrate on making this 0. Okay, so that will then take you to here, and then looking at this, factorize it. It will then give you this. When you're here, when will this equal 0? This equals 0 when this thing is 0, or when this thing is 0 here. Okay, so basically our inflection points occurs when x equals 0 and when x equals the cube root of 10. So what that means is that looking at our graph here, we've got an inflection point here, and then we've got an inflection point somewhere at x equals the square root of 10. So if you want to know the value, then you would then put this into here. So when you cube this thing here, it will become 10. 10 plus 2, that will be 12. So it will be the fifth root of 12. Okay, so our inflection point occurs at x equals this, comma this. Okay, so this is the y value here. Okay, yeah, so the inflection points occur when x equals 0 and when x equals this. Okay, and by the way, when you look at the second derivative, when you get to this stage, remember something weird happens here. Okay, something weird happens at x equals the cube root of -2. But when you get to the second derivative, when you get to this stage here, when you differentiate it twice, you get f double prime equals this thing here. When you look at this, find out when this thing here equals 0. When this thing equals 0 is when this here equals 0. We've done that. So when you get to this stage here, also notice that this whole thing here breaks down when this thing equals 0. Okay, when the denominator equals 0, then the whole thing here breaks down. And as it turns out that this thing here equals 0 when x equals this. So again, f double prime breaks down when x equals this. Don't forget, when x equals 3, the cube root of -2, f prime breaks down, f double prime also breaks down. Okay, but yeah, so just bear that in mind when you get to this stage here. Just learn to spot that this thing here breaks down when this here equals 0. Okay.